unit of rate of reaction. See, as we know that the rate is equal to change in concentration upon time interval, we can know certainly what will be its unit. See, change in concentration is expressed in moles per liter, and time can be expressed usually we do in seconds, or it can be in any other terms. It is taken as time. So it is basically moles per liter per time, and if the time is taken in seconds, remember it will be moles per liter per second. So this is what is the basic unit of the rate of a reaction. Now you also, let's move to the another type of the rate of reaction. See, remember the method which we have studied is called, as I have told you, the average rate of reaction, because it gives us the average for the time interval delta t. But remember, if we have to find out the rate at any particular instant of a time during the course of the reaction, we can't find out by this method. The reason being, it is giving us an average. I can give you an example. Let us take example of, let us understand this graphically, that we have plotted a graph between concentration and time for an example in which A moles of A changes to B moles of B, and the concentration of A is varying like this. It's almost is like coming out to be like this. Now what we find is, we have taken the readings at 5, 10, 15, 20, 25, 30, 35 minutes like this. Now we know we can have the rate of the reaction, average rate of the reaction for any time interval from this data. We can find it out. But suppose somebody wants to know that what is the rate of the reaction at 22nd minute. So rate at 22nd minute. Suppose this time is taken in minutes. We don't know because we are not having the data. So what we will do is, yes, this we can find out by what? By take from the 22 minute point, we can draw a perpendicular, and the place where it cuts or intercepts the curved line, we can draw a tangent from that curved line, and we can find out the points of intersection of this tangent on y-axis and on x-axis. Let it be y, let it be x. So this OY will give us the change in the concentration for at time interval for at time 22 minutes, and this OX can give us the time interval. So we can find out the rate at 22nd minute as OY upon OX, because this will give us change in concentration upon time interval. So this is what is the method which is going to give us the rate of the reaction at any particular instant of time, and that is why, remember, this type of rate of reaction is called instantaneous rate of reaction. So what is instantaneous rate of reaction? The rate of a reaction at particular instant of a time during the course of the reaction is called instantaneous rate of the reaction. How it is determined? It is determined graphically by drawing what? Tangent from that point at which you want to know the instant rate, and that tangent, tan theta, is going to give us what? The intersection on the y-axis and x-axis, and from those data we can find out what will be the rate at that particular instant of time, like this. So this graphical method is basically instantaneous rate of reaction.